Your first goal is going to be to describe the motion of a person on a position versus time graph. Let's get started. A graph shows the relationship between two things. In a moment, I'm going to do an activity with you guys that graphs my position versus my time. Let's do this. Follow along with me and predict with me as you go. For this activity, you're going to use the motion detector, CBL, to make a graph pattern by moving in front of a wall. We're going to start with this graph. We're going to make this graph using the CBL motion detector. So let's take a look at our first graph. I want to take a look at the axes. On the horizontal or x-axis, this is represented by time. Time is 0 in the left-hand corner. On the y-axis, the one that goes straight up and down, vertical, this is represented by position. Again, in the corner, the position is 0. That means we are closest to the wall. We're going to start with this graph. We're going to make this graph using the CBL motion detector. Notice how this graph and this graph match. The next thing you're going to do is predict what I have to do differently for this graph. How do I make the slope a little bit less? So what did I do differently there? In the second graph, I moved a little bit slower. Now let's do this one. What do you think is going to be different about this one? So again, we see we have this line going down, matching this line going down. I could have gone a little faster over here. But what was the difference? Why did this line start here instead of down here? Well, it had to do with my position. Up here, I was close to the wall. Over here, I was far from the wall. Predict. What do you think I have to do differently to get a line that looks like this? Ignore this part. So what did I do differently to get a line that looks more like this? Well, I started away from the wall again, but this time I went slower. All right, next page. Whoa, my God. How are we gonna do this? So I want you guys to predict. How are we gonna make a pattern that looks like this? Here we go.
You're going too slow. It's not going to work. Maybe it will. Nailed it. You can edit my voice out of that.
All right, let's see what we got. Ooh, not bad. Miss Moore needs to go a little faster. All right, so you can see we start close, further away, closer, further away, and end close, just like over here. All right, these keep getting more and more complicated. So again, pause the video, predict what you are gonna do for this one. What would this look like? Here we go. See if I can remember. see what happens. Oof, it's a little rough. Okay, but you can see here that we are getting, starting far, getting closer to the wall, moving away, chilling, moving far away. Boom, nailed it. All right, now take a look at this slope. It's not a straight line like it was before. Think about what we did differently between this slope and this slope. Predict, what am I gonna do to get my slope to look like this? Here we go. Yeah! All right, here we go. All right, so as you can see, it gradually increases. Now think about, how did I get this? How did I give that gradual increase? Well, I started off slow and close to the wall, but I started off really slow and then I increased the speed that I left the wall. Now predict, what am I gonna do differently here? Here we go. Okay, all right, not bad, not bad. All right, so you can see that the slope starts off a little, it goes pretty fast, and then it kind of gets a little slower up here, just like how I did. I went fast, 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 slow. Fast, 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 slow. This is your first assignment for the lesson. It says the graph below shows the motion of an object over time. Time on this axis, position on this axis. Describe the motion, using words, of the object for each time interval, from 0 to 1, 1 to 2, 2 to 3, 3 to 4. Now one trick that will help you with this is to turn this way. Use a piece of paper. Now for position, you have the positive and the negative direction, and you can take a look at what happens as time goes by. So take a look at what happens to the line as time goes by. That's the first interval, the second interval, the third interval, and the fourth interval. The slope is rise over run. On a position versus time graph, the slope is the velocity. So the velocity equals the displacement, the change in x, over time, or the change in time. Now let's make a t-chart to look at this. All right, so now we're gonna make a t-chart using the x and the y-axis. So on the x-axis we had time, on the y-axis we had position. And we're gonna start with 0, and we're gonna put down all the seconds that we have. 1, 2, 3, and 4. So at each time that's on here, you're gonna write down what the position is. Here is how you calculate the slope, which will give us the average velocity. Before we describe the motion using words, now we're gonna calculate it using an equation. So if you take a look at the slide, it says average velocity, represented by v, equals the change in x, or position, over the change in time. The change in x is the same thing as the rise, and the change in time is the same thing as the run. So basically, the velocity is the slope. In order to find the velocity, you do the final position minus the initial position, divided by the final time minus the initial time. So where did these numbers come from again? Oh yeah, up here. Okay, so let's go ahead and calculate the average velocity. So let's take a look at these numbers. These two numbers are gonna go together. Ding, ding, these guys, and these guys. All right, so we're gonna go ahead and calculate the average velocity from 0 to 1 second. From 0 to 1 second. I'm gonna go ahead and put 1 second here, minus 0 seconds here. Okay, over here again, so it's gonna be from, here it was 0 to 1 second, over here it's gonna be 1 to 2, 2 seconds minus 1 second. Boom. Okay. Over here it's going to be from 2 to 3. 3 seconds minus 2 seconds. And over here it's going to be from 3 to 4. 4 seconds minus 3 seconds. So from 0 to 1 second, we're talking about this slope right here. We're going to calculate the slope of this. From this segment, from 1 to 2, we're talking about this slope. So we're going to calculate the number for this slope. From 2 to 3, ooh, that's this guy right here. Okay, and then lastly from 3 to 4 seconds, that's going to be right there. All right, so let's go ahead and calculate this first one together. So on the bottom, we have the change in time. On the top, we're going to need the change in position. So for 1 second, the change, we were at position 2 meters, subtracting at 0 seconds, 2 meters up here. And at 0 seconds, we're at position 0. So that's going to go right there. So let's go ahead and plug that in. So 2 meters divided by 1 second, that's going to get me 2 meters per second. And again, this is my average velocity. This is the slope of my line. I'm going to go ahead and talk through this one with you guys. So you are going to want to look at our data table and look at the graph and figure out what was the position at for 2 seconds and what was the position at for 1 second. You're going to plug those numbers in here, subtract them, divide, and get your slope. Then you're going to do the same thing for this one and for this one. Now that we've finished calculating the average velocities, let's go ahead and take a look at the graph. Now keep in mind, the average velocity is also a vector quantity. The direction of the velocity is the direction of the displacement. So as you go from 0 seconds to 1 second, the direction of the displacement is positive, which means you have a positive velocity. As you go from 1 to 2, the displacement is 0. You have a constant velocity. As you go from 2 to 3 seconds, the displacement is negative, giving you a negative velocity. And as you go from 3 to 4 seconds, the displacement is positive, giving you a positive velocity. What is instantaneous velocity? Well, what is an instant? An instant is an extremely small amount of time. It's however fast you're going in that very instant. So say you are driving down G Street and you look in your rearview mirror, you see a cop, and you're like, oh, how fast am I going? You look down at your speedometer and you see that you are going 38 miles per hour. At that very instant, that is your instantaneous velocity. And you put the brakes on and you look back down at your speedometer and you see that in that instant, you are going 30 miles per hour. That is your instantaneous velocity at that instant.
And go.
The rate of change of velocity is acceleration. So how would you describe the motion of the ball as it goes against the table? As it rolls against the table, you can hear how fast it's going. For this activity, we are going to ignore this side. What I want you to do is listen in order to describe the motion of the ball. I want you to think about the motion of the ball as soon as I let it go, the noise you hear, and at the very end, the noise you hear. What does that mean for the speed?
Go.
This is the definition of average acceleration. We have the change in velocity over the change in time. It's important to note that these are instantaneous velocities. This is the instantaneous velocity at the very, very beginning. This is the instantaneous velocity at the very end. We divide this by the time it takes to do its thing. Now let's go and look at some different velocities. All right, so we've seen this before. It's accelerating down the ramp. It starts with an instantaneous velocity of 0, and it finishes with a faster velocity. It's accelerating. What's the difference when we do this? One more time, that one.
What's the difference when you do this?
At the very top now for this one, the velocity is 0. And at the beginning, it's faster than 0. So here, we're not accelerating, we're actually decelerating, which is also an acceleration. So what does this mean for our equation? Well, what this means is that if our final velocity is bigger than our initial velocity, our acceleration is going to be positive. If our final velocity is less than our initial velocity, our acceleration is going to be negative, or a deceleration. And what does positive or negative mean? It means the direction. Velocity may change either its magnitude, speed up or slow down, or direction. You can feel it when you experience an acceleration. So think about these different scenarios. You're jamming on the freeway, you're going super, super fast, and you put on the brake because there's a traffic jam. And you feel yourself kind of lunge forward. This is an acceleration that you experience. You're stopped at a stop sign and you're racing your friend next to you. You take off and you feel yourself being pushed back. Is something moving you? No, it's acceleration. You are driving and you're about to take this turn really tight, okay? And as you turn, you feel like you're being pulled out. Is something pulling you out? No, you're experiencing acceleration.